Investment in knowledge pays the best interest. Good morning, galaxy of intellectuals, resource person, Dean YCT, HOD of Electrical Department, faculty members, and participants. On the day of Faculty Development Program on Clean and Green Energy for Sustainable Development, we welcome you all in the gathering. It's a matter of great happiness to welcome you all in the Faculty Development Program organized by the Department of Electrical Engineering. Success is not the key to happiness. Happiness is the key to success. If you love what you're doing, you will be successful. The principles of sustainable development say that we should live within environmental limits and that we should enjoy and aspire to a healthy, just, and fair society. Keeping this in mind, department has organized a faculty development program on clean and sustainable development. Now, I would like to invite HOD Electrical Department YCT Engineer Lavnish Talwar for the welcome address.
Thank you so much, Esli. Esli, it is audible?
Yes, sir.
Okay, thank you. Thank you so much. Just a minute. So, a respected and honorable speaker of the day, Dr. M. MARSALINE BENO, Chief Coordinator YCT Engineer B.R. Verma sir, Dean Academics YCT Engineer Dinesh Gupta sir, heads of the departments of Yogananda College of Engineering and Technology, faculty members of Electrical Engineering Department, and most important all, the dear participants. A very good morning to all of you. It's an immense pleasure for me to formally welcome our resource person for today's talk on 5 days FDP program on clean and green energy for sustainable development from 21st to 25th February 2022, organized by the Department of Electrical Engineering at Yogananda College of Engineering and Technology. So before handing over the entire platform to our resource person for the day, Dr. M. MARSALINE BENO, let me introduce to all about BENO sir. BENO sir has a very, very rich experience in teaching, and presently he is holding the position of Vice Principal at St. Xavier Catholic College of Engineering and Technology. He has more than 10 years experience as a HOD as well as Dean. He has a Vidhan score of 9.7. He produced 7 PhD scholars. 10 scholars are pursuing under his supervision. 12 PhD scholars completed under his doctoral committee guidance. Received around 20 awards. 13 SCI index paper published. 15 Scopus index paper published. 206 citation and 7 in H index factor. 5 technical books and 3 non-technical books published. More than 100 lectures delivered as a resource person. Leadership in international professional bodies like IET, IGEN, IEI, and certified home energy auditor. Recognized innovation ambassador of MIC MHRD. Project qualified for funding from AICT RPS scheme. 2 projects are under process. Institutions PFM nodal officer. Institutions IIC president, and institutions CI coordinator. This is the brief profile of our resource person for the day. Now, today, Dr. Benno has delivered a talk on artificial intelligence and IoT as a sustainable development. Artificial intelligence can contribute to sustainable development by helping to predict the errors and plan sustainable development goals more effectively. According to the study, artificial intelligence could help achieve 79% of sustainable development goals. Artificial intelligence and IoT technologies used together can improve the environmental sustainability by reducing the waste, pollution, and protecting the environment. Today, he will deliver a talk on artificial intelligence and IoT for sustainable development. And I hope that at the end of the talk, all the participants get a great benefit from this talk. One thing personally, I will tell you about Benno sir, that Benno sir is a very great man of great visionary. He is always a down-to-earth man and always trying to help in students, fellows, and their colleagues in their academic prospective cases. I am very grateful and acknowledge that during this COVID pandemic, when our learning will change from offline to the online mode, and we are all passed through a very tough and bad conditions. Fortunately, I got a chance to meet with Beno sir virtually, and from his cooperation, I gained a lot of things. So thank you so much, Beno sir. Beno sir has already delivered. Beno sir has already delivered many talks on entrepreneurship and innovation at IIC Cell of YEC. Now I welcome the Chief Coordinator YCT Engineer B.R. Verma sir and Dean YCT Engineer Dinesh Gupta sir, who always inspire us to do such type of activities and always motivate us. Thank you so much, B.R. Verma sir, as well as Dinesh sir, for his valuable and precious times and become this part of this faculty development program. So this is all from my side. Thank you so much. Hand it over to Esli.
Thank you very much, sir, for your kind words. Now, I would like to invite the resource person for the fourth day of Faculty Development Program, Dr. M. MARSALINE BENO, Professor and Vice Principal, St. Xavier Catholic College of Engineering, Tamil Nadu, India, to conduct the session on El-Ano IoT for green and sustainable energy. We welcome you, sir.
Good morning, and thank you so much. Especially thank you for a great and smart introduction about me. Thanks to Professor Launis Dalwa, HOD Tribute Department, the coordinator of this FTP. At the outset, I'm really very happy. All the participants, faculties are really, they are spending time to learn the important thing, the need of the day. The society, the globe is need the sustainable, clean and green energy. So this FTP, I am also one of the part. I can also share some view. So at the outset, once again, thank you to all the organizers and participants. Now, just a minute, I will share my PPT and we will start the presentation. So my PPT is visible.
Yes, sir, it's completely visible.
Yeah, once again, welcome and good morning to all. So today's topic, artificial intelligence and the Internet of Things for green and sustainable energy. Here, only 5 things, the major area I'm going to cover. Why sustainable development goals? Because today's world scenario, we are following sustainable development goals. 2030 is a target. There, the 17 goals are there. 7th goal is our topic. Sustainable development goal number 7. That is a clean and green energy related one. So just I will cover about SDG 7. Then green, clean and renewable energy sources, the basic things are introduction. Then our point, AI for green energy, IoT for green energy, and both AI and IoT for green energy. So the background, today we are living in a scenario of very global warming. Impact of global warming is already there. We are experiencing the rising level of sea is increasing. So that coastal flooding, and every year the forecast 2030 some meter sea level may rise. In 2050 again the sea level will. So many cities are going to covered by the sea level, sea water. Like lot of issues we are facing because of the global warming, melting glaciers, excessive. Another side, excessive rainfall. So because of climate change, excessive rainfall and floods, like Amazon wildfire, lot of destructive wildfires are happened. And another side, acute water shortage. People in South Africa, so many countries, they have water shortage, acute water shortage. Emission of carbon dioxide, the major cause of global warming. There is a survey in 1958. Carbon dioxide concentration in the atmosphere was measured at 316 ppm. After 130 years, that is in the year 2016, it was 407 ppm. So within 130 years, this increased 45%. Now again, after 2016-22, it may increase more. So this is a problem. So the pollution, air pollution in our India, Kanpur, Delhi, these are very air polluted city. Mumbai is fourth air polluted. Like so clean water, clean environment. So after lockdown, during the lockdown, you can see there is a without air pollution in India yet. So sustainable development is need of the day. That's why United Nations formed this Sustainable Development Goals, 17 goals. So why it is needed? Because the natural resources are going to exploitation. So very soon, like 50 years or 100 years only, we will use the fossil fuels like petrol, diesel, or any natural gas. It may come around 100 years only. So the damage is already caused by in the environment, ecology. So insecure for the future human beings. So the sustainable development, it is not in the new one. From 2000 itself, they started as Millennium Development Goals. Then 2012, they started a conference on Sustainable Development Goals. During the Paris Climate Conference 2015, they announced the 17 goals. And the target we have to reach before 2030. That is our target of Sustainable Development Goals. In summary, there are 17 goals, 169 targets, 230 indicators. Like a lot of plannings are, it is not for some country, it is universal for all countries, and it is for individual, it is for all the institutions, industries, everywhere, all. So these are the 17 sustainable development goals, starting from no poverty to parameter partnership for the goals. There seventh one is our area. Now we cannot discuss all the thing. Mostly faculty members know about these sustainable development goals because everywhere this talk is there. All the countries are involving. India also taking lot of things. Prime Minister's National Missions scheme and lot of schemes are there for this sustainable development goal. The seventh one, affordable and clean energy. So this SDG, there are divided into three categories for economic purpose, society, environment. The society purpose 1 to 7, 11, 16. So this society means that our earth, what are the things we can improve. Their seventh criteria is the clean and sustainable energy. So here there are three targets are there. By the year 2030, universally affordable, reliable, and modern energy services. At present, 750 million people in the world, they are not getting proper electricity. So, but we are planning in the year 2030, affordable, reliable, and modern energy services for all. Again, by 2030, substantially the share of renewable energy in the global energy mix. So, at present, less than 20% only the renewable energy share is there. Remaining 80% from fossil fuel only. The fossil fuel consumption all over the world is increasing day by day. So therefore, the need of this sustainable development goal, similarly the third target, energy efficiency also the target is there. In India, if you take the summary, near 84.5% of people only getting the access to electricity. So still 15.5% of people in India also not getting the proper access of electricity. So our aim is 100% electrified in the year 2030. Similarly, so this 31 million houses still we have to do electricity and uninterruptible power supply and renewable energy also we have to target now 175 gigawatt to so at least in 2075 the Prime Minister announced net zero, that means no carbon emission, fully renewable energy like that. So this is a status. So seventh sustainable development goal, ensure access to affordable, reliable, sustainable, and modern energy for all. This is possible only artificial intelligence, IoT, like modern technology also incorporating in the current scenario. So renewable energy sources is the only way. We all know that the energy management pyramid, the bottom is actually energy conservation. Energy conservation means we have to on off properly, correctly, whether energy is needed, whether the electricity or any energy is needed, properly on off. Okay. Second, in the middle of the triangle pyramid, it comes the energy efficiency. Whatever tool, device we may use efficiently. The top one is renewable energy. So renewable energy is the top one in the triangle of energy management. Everyone know that in renewable energy, there are a lot of issues there. That only we are going to discuss, and how to overcome the issues. The solution is AI and IoT. So we need smart energy. So smart energy is a key driver of economic growth. Whatever the issues in a Sustainable Development Goal 7, we are generating power, we are distributing power, but still we cannot reach. There are a lot of issues are there. So smart energy is a key driver of economic growth. And the industry 4.0 is started. The 3 C's are there: control, compute, communicate. So here, control and compute is possible by artificial intelligence. AI is a program that can sense, that can reason, that can act and impact. So it can control, it can compute. First of all, calculate or compute, then control. And we need communication, third part. So that part is by Internet of Things. So IoT is the Industrial 4.0 communication tool, or the most and best communication technology is IoT. So these 3: control, compute, communicate, that is the need of Industry 4.0. That also solved by, that also satisfied by AI and IoT. So they together, the renewable energy become smart system. So AI is and IoT jointly, the renewable energy and smart grid system can be designed, can be simulated, can be controlled, fault diagnosis, fault tolerant control, a lot of things can be do. So electrical energy demand also managed by AI and IoT combinedly. That is a basic idea. Now we will start from the thing is, everyone are thinking clean energy, green energy, renewable energy are same. Is it same? There is similar, almost the same. Little difference is there, because everyone know clean energy means that there is no pollution, clean air. Green energy means it is from nature. There is no artificial power plants. Sources are from nature, or there is no converting some farm to some farm and making wastage without any wastage. Sources from nature. Renewable energy means recyclable source. The source is continuously available. It is not exploiting or going to end. Recyclable sources. Now here, for example, if you take hydropower plant, this is a renewable source because water is coming from rain. It is a renewable source, but it needs the dam, large area construction. So it is not green energy. Sometimes many experts are telling it is a renewable energy, but not a correct green energy. Like nuclear energy. Nuclear energy is a clean energy. There is no pollution, but there the nuclear fuel is not a renewable one. The fuel, uranium, thorium, that may be not a renewable one. Like, so other actually solar energy, wind energy, geothermal, tidal energy, these are comes all renewable, green energy, clean energy. So these energies are better because of low carbon emission. Everyone know there is no carbon dioxide emission. Therefore, it is clean and it is safe also. There is no dangerous production, no products, dangerous product. And ample energy, that means lot of source available. For example, solar energy, the sun's total energy is more than sufficient for all over the earth requirement. And it is 10 times of the requirement. So sufficient energy like wind energy, all are ample energy available. Green energy, so it is a healthy environment without affecting the environment. And technology also, like not a simple fuel. So many technologies are available. Nowadays, AI and IoT, that also help in a many way. Now, the problems are, few problems are there in renewable energy or the green energy sources having weather dependent. That means wind energy means it is climatically, it is monthly monsoon based changing. Even solar also, during rainy time, we cannot get more solar radiation. Like, so weather dependent and geographic dependent. So it is variable to country, content to everywhere it is changing. It is geographic. Some places the time of solar is different. Again, wind monsoon is different. And major thing is high setup cost. For windmill, we need a high setup cost. Solar, all the power plants setup cost, initial cost is very high. Space requirement also very high. Space requirement means, for example, we can see 100-hectare area. Solar panels only produce only 50 megawatt. So you assume how much space is required. Similarly, windmill also 3-acre area required for 4 megawatt production. So the space requirement is very high. And the large storage capacity. For example, the production is we cannot stop. It depends on the weather. It depends on the geographic dependence. So we have to store the energy. Sometimes the wind energy is available day and night. We can store if there is no demand, but we can store. So large storage capacity is required. Again, the DC conversion. So battery, like a lot of storing problem is there, and some harmful to wildlife, like wind blades are making disturbance to the birds, or the heat produced in the solar panel may disturb in the small birds, like some harmfulness also there. The major challenges, issues in the renewable power sectors are unpredictability of weather. So we have to find a solution of prediction, weather prediction. So that is possible by artificial intelligence. Again, implementation of energy storage. So how to choose what time, what capacity, that also selection, that also possible by AI. Then infrastructure is big challenge, cost issue. Still people are working on it. Smart, nowadays the solar panel or even wind tower also, wind plant also, initially the one windmill can produce 10 kilowatt, then 15 kilowatt, later it improve 100 kilowatt, now in megawatt, again megawatt to 1 megawatt to 5 megawatt, 10 megawatt, like that. Now the requirement also there, many smart materials are available. So that is possible, and smart control by AI is possible. Electric grid management and information barrier, how to manage the data. These areas are very, very troubled. So that is very solved by, that problem is easily solved by artificial intelligence. And issue in power quality, that also solved by AI and IoT. So in general, artificial intelligence can be used for, and IoT both used for energy forecast, energy optimization, and energy tracking. We can classify into 3 areas. Energy forecast means prediction. So based on the data, so now the big data handling techniques are there, and machine learning combinedly we can predict weather, predict the wind speed, predict the solar radiation, all the things are predicted. So we can forecast what time, what this time, how much power can be generated by this solar panel. Like that we can plan. So once we know the exact forecast, so we can plan how much power plants we can connect or disconnect. Like, so we can manage energy forecast, so that optimize. So the production energy optimization means production is optimized. The needed energy, if needed from storage, or it is excess means store. and distribution, like energy optimization is possible. Okay. Now energy tracking, this is also very important, using smart meter. Energy consumption is controlled. So decision and cost saving model, what time we can use, like energy tracking also one of the major application of AI and IoT. Now we'll start, basically AI is, we can say, 21st century achievement. 21st century, the earlier 20th century electricity problems are solved in AI in the 21st century. So this here you see the blackouts. Even every 5-10 years, blackouts are there in all over country, all over the world. So that means blackouts means complete breakdown of all the power plants. If the shortage of power, it leads frequency change, so that all breaker trips, all the power plant, everything out of synchronization, out of grid, that happened frequently. So these problems are cleared by 21st century achievement of AI. So artificial intelligence is a one step ahead for sustainability. Now I will say a few things about AI, because we will discuss AI based, artificial intelligence based clean and green energy. Now the basic thing of AI, I already told, AI is a program. It's a simple program or a big program. It's a program that can sense, reason, act, and adapt. So there are two things it can do. It can compute also. It can find adaptation or action, giving changes, suggestions. All the things are possible. It can sense means it can know the things. It can identify the value. So AI is a simple program. Many of you think it is a hardware device. So that is a robo. Hardware may be robo, hardware may be IoT. Now, there are three types. Some researchers are saying weak AI and strong AI. Some literature, super intelligence also there. Anyway, weak artificial intelligence means the name itself, it is telling. Actually, it is limited domain. Example is single task. This artificial intelligence program can do only one work, single task. Example, Amazon's Alexa. So only it do the translation, or it understand the language. So the language, natural language processing, NLP is example for, NLP is one type of AI. It is example for weak AI. That means only one work. Only limited work, limited single task can be do. Many examples we can see, like Apple Siri, Google Assistant, even the robo used for obstacle detector or line following detector. These are only one task. They are called weak AI. But for our application, energy applications, we need strong AI and super intelligence AI. What is strong AI? Strong AI means, and it told weak means limited. So strong means multiple job, multiple task. It is broad. For example, so many companies are there. AG technology is famous for this multiple task. Like now, all our energy optimization and energy prediction, all the applications, we are using the strong AI programs. Normally, different types of neural networks, multi-layered neural networks, and many algorithms we can use, genetic algorithm or hand-colony. Lot of computing intelligence here used for calculating or controlling. So they are strong AI. Super intelligence means, again, it is more powerful than strong. Multiple tasks in accurately, fastly, like we can say super intelligence means the capacity also more. So it's a strong intelligence like a human, but super intelligence is above the human. But super intelligence is the what we say, it is in future it may be a issue for human being. It may be the problem for human being, because the super intelligence can control human being. Like that, the issues are also coming in future. But we need a strong AI enough for our energy related applications, a lot of approaches there. Thinking like humanly, thinking rationally. That means logically, and it can acting rationally, and it can do action. Like a lot of approaches are there. Main goals of AI is actually creating expert system and implementing the human intelligence in machine. So like human being, computer can do. That is a main objective or goal of AI. We all know data science and AI are similar, or not similar, they are connected. You can see data science and AI. Data science, this part. The major part of data science is used for AI. So in general, artificial intelligence needs data science. Without data, it cannot sense, it cannot act in or all the things. They're not controlled. Artificial intelligence, other subgroup machine learning, another subgroup deep learning. So deep learning is also AI, machine learning also AI. In general, AI, the inner machine learning actually many multi-layered neural networks. Like artificial intelligence means even weak AI also okay, one task, single layer. But machine learning, more neural networks, and so more calculation. There so many types are there. So supervised, unsupervised, like that, semi-supervised, reinforcement. In the deep learning means it is very deep, multi-layered. Again, more data. Network is multi-layered, more analysis and calculation part with the help of more data set. So deep learning, for a single task, it takes a lot of accuracy, lot of process. So simply here actually first one is a machine learning, second one is the ordinary learning or traditional learning. Ordinary learning, what we are doing, data plus rules. The rule is important, if else rule, whatever rule, based on only the computer program is doing, giving result. C program, any program, we are giving data and some formula or some rule, so the program gives the result, just output value is like that. But machine learning, data plus desired result. So for this, what is the result needed? For this data, what is the result needed, required? That given to computing machine, so the computing machine make a program, give the output as a rule or output as a program. That program can do like a man, that can do for applications. That is the difference of ordinary learning. So here machine learning, supervised learning is there. Unsupervised. Supervised learning means like a teacher with the student learning. We all know input output. So for the known input and known output, we are learning like neural network or anything. The networks are learned, supervised learning for this input, for this output, like that. So once the supervised learning is learned, the model is ready. If model is ready, unknown input is given, it gives the output. That is a supervised learning. So for known input and output, the model system or the supervised learning algorithm develop the model, develop the neural network. So it is a supervised learning, and normally there are two types are there, regression type. Regression also many types are there. Okay, classification, regression. So it can classify it is correct or wrong, good or bad, or condition for input. Based on input, it will tell whether the solar panel need to on or connect, or whether the windmill, wind power plant can be connected to the grid. Like the based on input, classification work. Another one is it can also give the value, prediction. So these two things, prediction and classification, is possible by supervised learning. So most of our energy applications, supervised learnings are used. And unsupervised learning means like prediction, market analysis, using clustering in a group. It is nearest one, like that. And reinforcement learning means like robo. It is action, controlled action is there. Now, some applications of artificial intelligence in renewable energy, some AI application apps are there. Now you can see for smart grid, smart monitoring, smart meter, maintenance work. For these are some apps are available. Smart home, smart meters, decentralized plants in the coordination, forecast in the power plants, or electricity trading. We can give the forecast of bills, algorithm trading, monitoring trade. So using AI, a lot of apps already available. So here we all already know solar, wind, these are the renewable energy sources. For all the renewable energy sources, we can use AI applications, either energy forecasting, energy efficiency, energy accessibility, power scout. So the data, power scout means data, like SCADA, it takes all the data. Once the data will be useful for future operation, future monitoring, fault analysis, fault-free operation. For all this, power scout also needed. So a lot of machine learning techniques are there, ML, hybrid ML, SOC. These are some algorithms and some challenges also there. Availability of power issues in power quality and resource location, information barrier, cost issues also there. These are so anyway, artificial intelligence can used for increase in energy efficiency in storage, accident management, grid management, energy consumption, energy forecasting, energy accessibility, and renewable sources. Now, these are all the companies already developed for AI-based applications, AI-based energy efficiency applications, Metroscope, Bidsley, Verdigris, Verb. These are already developed for real-time analysis for energy consumption, like smart home. Verb can, this company can already generated an app that is useful for smart home or smart industries. Energy consumption prediction by Verdigris. And Metroscope, that app is used for power plants and industrial facilities. I mean, grid edge, that is used in the grid. So many other apps also there. Google DeepMind. This AI app is brought by Google in 2014. So this also one of the best thing for power monitoring or power consumption optimization. So using the minimizing Google's servers, 40% it can minimize. Verdigris Technologies, already told, this is also one of the forecast AI. Power consumption is monitored, so data can be monitored. Like consumption is possible, smart consumption. That means we can save energy through Verdigris technologies. The sensors in the industry or houses, wherever, they will operate need-based. Need-based means it depends on the weather or ambient conditions, environment condition-based operation. Again, Verb, this is actually data collection thing. So this will be used for decision taking, power scout, so power data collection, like many things are there. For wind power also separately, many apps are there for wind forecast, weather and wind generation, process contracts and agreements to make better decision and development. So here, same Vaisala, it's for solar and wind, Greenbyte. So solar also same companies are there available for forecasting. One research recently my PhD scholar done, application of AI techniques for solar radiation prediction and modeling. Actually, what he done means he did all the experiment, all the data collection, shading, unshading, partial shading, and with the different panels for 100 watts panel, for 300 watts panel, different companies also, crystalline, polycrystalline, monocrystalline, different make. So for a 6 months reading and that area, so the output power, output actually input side, the actual climate condition, irradiation, the solar irradiations, humidity, wind velocity. So we have a weather station, all the data taken. Now using the neural network, he given the supervised learning. So for 100 watt panel, for January month 1, what is the actual power? Second, and every time, morning, evening, So now this 100 watts panel can be used in this area because it is location based. We can predict, so how much needed, how much panel required for this day, how much panel can produce. So like many energy prediction, not only neural, many fuzzy, support vector machine, SPM, genetic algorithm, gray theory, nonlinear time series, these are all actually AI techniques can be used for this prediction. So both smart grid means not only renewable energy, apart from renewable energy, smart distribution, smart transmission, smart monitoring, all the area we can use artificial intelligence. So AI is a major tool in the power grid or energy side, renewable energy. Now we'll hybrid energy, another one. Hybrid energy means combining more than one biogas and wind energy or all renewable, solar, microgrid, hydroplant, micro hydroplant, geothermal. So here management system is very important. So the need of the grid, need of the load, that is controlled by, again, how to store or discharge from storage, battery, capacitor, fuel cell. These all managed by AI techniques. There is also one powerful research. So it clearly identified the hybrid operation is possible. Earlier, the hybrid operation, a lot of energy waste because we don't know how to integrate. So the integration of renewable energy sources are better and optimized way through this artificial intelligence. There are a lot of approaches are already there. These are taken from their literature survey. Graphical construction, so many optimization techniques, determinants approach, linear programming model, dynamic program model, nonlinear programming, hill climbing. So they all having different characteristics. They all used for PV, standalone PVR, all the applications also. Similarly, different algorithms, genetic algorithm, particle swarm optimization, fuzzy logic, artificial neural network, say like all the taboo search, all the algorithms, each lot of literature review papers are there. All the researchers starting from 2000 onwards, recent years 2017, 18, 21, lot of articles are there, especially lot of Springer and Elsevier series article. That means conference publications also there. So they are applicable for hybrid renewable energy system, solar, wind individually and combinedly, and backup storage system. Mainly optimization purpose, many papers are there, the anti-colony and these optimization techniques. PSO, fuzzy logic, these are used for hybrid operation, that means management. And hybrid renewable energy system, all the other algorithms also used. Now one example, this is a optimization technique of solar using AI. So where we can optimize means, this is solar photovoltaic array. This is a boost converter. This is the main thing from the DC to DC. Or power measurement unit is there. We can measure whatever. Here this MPPT is the maximum power point tracking. Here this is only the area we can do. So MPPT is controlled by fuzzy logic, neural network. So here one example is neural network based. So this MPPT control, this actual circuit diagram, their neural network is used for giving the signal for the here MOSFET. So the boost converter, this is a real circuit diagram. This is a block diagram. Here MPPT is optimized by a neural network or fuzzy logic. Similarly, wind turbine also, there also MPPT controller is there. So both the generator side, because double side winding induction generator means double side. There you can use fuzzy based, all the fuzzification, defuzzification process. They used for finding the gate signal, firing angle for this controllers. Controllers can convert the converters like MPPT controller. Similarly, lot of applications are there. Lot of methods are there. For example, performance assessment of wind turbine. lubricant pressure monitoring. So monitoring is very important in the wind turbine. Their pressure monitoring, lubricant temperature monitoring, blade fault detection. Before fault, we can identify, means we can stop it and we can clear it. Wind turbine gearbox fault detection, like all the diagnosis is possible through AI. So these are all, some companies are softwares. We can all, otherwise we can say softwares are available. They emerged for all applications to hybrid renewable systems, hybrid renewable energy sources. For that, these simulating tools means like MATLAB. From MATLAB, they enabled like hybrid, Hotjar, Transys, PV solution. If you enter in the Google, you can get these softwares. Solar GIS, PV GIS. So it can be used for simulating. So like, now we'll move to Internet of Things. Next 25 minutes, we will talk about IoT. First of all, IoT, everyone know, Internet of Things is not a new one. Nowadays, very popular. Everyone using mobile app, Android phone, everywhere IoT is there. We are controlling, we are pressure monitoring, blood monitoring, all the things nowadays possible. Like so many health wearable devices, everywhere IoT is there. So IoT used not only other applications, our renewable energy side also very powerful tool. Windmill, solar, all the renewable green energy monitoring and the energy optimization. So here in the Western countries like Canada, US, there even the cow is monitored. They are having farm. So everywhere they use a chip to the cow or animals, they can monitor where it is go, how much intake, like all the health monitoring. Nowadays, it is not new, it's already in practice. Industry also, it is monitored in centrally or remotely. Lot of IoT applications there. So what is IoT? Controllers, sensors or actuators plus internet. If you connect sensor or actuators with the internet, it is called Internet of Things. So anywhere from world we can see the input, we can see the data, we can monitor. So all the applications, not only house, industry, everywhere. So it is also connected people and things through cloud, through computing. So how IoT works means the data is taken or sensed from through sensing devices, maybe mobile or any sensing device. Through node, it is connected to, in the cloud, it is available. So everywhere it is connected. From any part of the world, we can connect. So normally nodes means it's a microcontroller unit or processor. There it also having sensors and it do wireless connectivity. It's a basic thing. All the things are connected, sensors through the node. And middle bridger or router is there, and finally storing area or cloud is there. A lot of IoT architectures are minimum 3 layer: application layer, network layer, perception layer, and improved version also there. Their own middle layer is connected, or SOA or 5 layer, so many things. Basically, all the layer IoT we need basically the identification, then sensing, communication, computation, services, semantics. So the up to sensing to application, a lot of areas are there. Internet of Things is not new. From 2000 onwards, a lot of starting is there. It's slowly increasing. Now around 2020, 7.6 billion people and 50 billion smart objects are there. So rapid development, 5 times faster than other electricity and telephony. 50 billion smart objects. It is again going to double, triple in coming years. So Internet of Things used for many applications, smart city, industry, even electric vehicle, smart agriculture. Now we can see actually smart energy, 13% is used by smart energy. That is our area. So lot of vendors are there. I mean, lot of companies, Sony, Luxi, Bureau, they all, Philips, even all the companies are, all the electronics companies are nowadays IoT based operations they are doing. IoT devices, radio frequency identification, RFID, electronic product code, internet protocol, wireless fidelity, Wi-Fi, Bluetooth, Zigbee, Ycet, like lot of basic communication tools are there with the help of only IoT, and all the smart sensors in smart home, basically from camera to so many sensors, touching sensor, proximity sensors, weather sensor, pressure sensor in the vehicle. There are also a lot of sensors. So it is not only smart home, industry, vehicle, smart city, wearable enforcement, health and fitness. Everywhere sensors based IoT is there. Now we will see few applications. One is the IoT based monitoring and control of smart grid, so that avoiding power theft. So basically Raspberry Pi is a processor used for IoT. It is easy to connect to cloud or Wi-Fi through or Zigbee. This project our students have done through Zigbee. And Arduino also we can use for connect one side. So the idea is power theft means from the input side and output side we are monitoring. Both same means there is no theft, but input side is increasing or high, output side is minimum. So there is a large difference, or that difference is theft. That like that this processor will calculate, and not only single houses, many industries, many places, many distribution sites we can use it. So next, automatic meter infrastructure, AMI. So here smart meters already there in the market. Smart meters, they are the thing using IoT only. They used to identify theft response, remote disconnect or connect, outage management, load control, energy accounting. All the demand response is possible through smart meters. So smart meters actually it's operating purely IoT based. So here every individual houses smart meter there is a processor, and then connected through home area network HAN, then outside local area network, wide area network, so that the data is used anywhere. IoT based distribution transformer monitoring, another application. The transformers are monitored, their voltage, their current, oil, mainly the temperature difference or oil sensors, these are very useful. So the maintenance of transformer, distribution transformer is easily done. So all the sensors, this will be any excess or abnormality means tripping the transformer and informing the personnel to change or doing the connect repair action. IoT based transmission line monitoring. So it is a large transmission line in the kilometer or hundreds of kilometer transmission lines are traveling. So there sensors in the particular places or frequent places or some locations they fixed with the frequent distances, so that they will use the IoT based. So they are not only their mechanical strength and other weather conditions, all the things, even the tree or nearby fault making things, all the things are monitored, so that transmission line is operating in a effective manner. It's from all other wind, all icing, any issues are avoided, so that uninterruptible power transfer is possible through IoT. So here condition monitoring. So 3-layer application layer, transmission layer, perception layer. Means application layer means here the remote control CPU, there we can monitor SCADA or data will be coming. So here transmission layer, here is the main substation. There the devices are there. They only transfer the they taken from all the transmission or distribution monitoring. Normally power plant mapping inspection, corridor mapping, lot of things. Even corona can be also. Corona means not our health corona, electrical corona. In the transmission line also monitor. Substation static line inspection, intermittent power, like many things is possible. So IoT aided transmission tower monitoring means, so IoT, every tower, the sensors are there, they are monitored from remotely centrally. Smart location based automatic energy control using. So here houses are a smart location based, their power can be controlled. That means we can on off from anywhere in the world, anywhere through internet, in your house, in your office, in your industry, all IoT based. It is everywhere. Already it is there, home automation. So Internet of Things based smart distribution. Smart distribution means ordinary distribution means there is only one way of distribution. Smart distribution means there is primary, secondary, backups are there, and it may be like a ring model, so that if there is a one path problem or failure, another path we can give automatically. The problems rectified, or we can back up the supply. That is a smart distribution. There, IoT based is very important tool, because they sense which side, even which side input problem means another input we can connect, or another distribution line. So energy provider, energy consumer, both are managed by IoT based input. And wireless sensor network monitoring in turbine. So even wind turbine, solar, everywhere we can monitor. So wind turbine we cannot go and see in the close. So the working people can see from anywhere through this wireless connection or through the IoT based inputs. So there are a lot of sensors there in the wind turbine for wind blades, for tower construction site, in the turbine speed, from the speed to rotation, torque, lot of things are monitored. So this is the IoT based smart monitoring and control of wind farm. So control is possible if the blade rotation, pitch, all the directions nowadays automatic is there. Automatic means IoT is inputted. IoT devices give the processor can give the signal or change the action, which direction change based on the wind direction, which direction rotate. So all the things are possible. So smart monitoring, not only optimizing, the monitoring means all the data are important. So that will be useful for future wind plants, or managing the power shedding, power, all other grid applications. Similarly, IoT based, so here one example. This is a simulations project actually. Real data is taken through IoT, all the data, sensors data is taken, and previous data, previous values like last year data. So here this is the AI program that will make a model. So neural network or genetical or any model. So we can predict this day, this time, what is this windmill produce power, but actual power, actual input with compare. So that change based analysis, again the model is changed. Our model is updated based on the real data, so that this modeling will be useful for predicting exact output. So next hour, what is the power we can, what amount of power we can get it from this wind plant? Like many plants, like we can model, we can design, we can utilize wind power in an effective manner. There the power quality issue is the variable power, variable nature of resource. So that is possible. Lot of advantages because of this big data. A huge number of thousands of windmills are there. Everyone through big data, this decision taken. AI and IoT together, the efficiency of operation is improved. And not only operation, maintenance and cost optimization, everything is possible through AI and IoT. This is another final example for smart home. Everyone know in our houses, it is there, smart homes, smart industries, smart buildings. So switches are smart. Again, the smart plug, smart switch, even any devices, a light, fan, everything is sensors connected, or air condition, fan, motion devices, everywhere sensors. So that need based, if the people are there, then only light on. If people are leaving, lights off, digitally on, and remotely we can control. And the maximum demand based control. If the demand is maximum demand is going to increase, means the luxurious things like AC or other things are switched off automatically. So home automation is simple application for energy conservation, and it may interconnected to renewable energy source also. So this is one example for solar monitoring, like wind, solar also monitoring. So there solar panel, many panels are there, which panel is working, which panel, some series connection panel problem means total set of panel output will be stopped. So here the net meter reading is compared, so that, and the total panel real exacted output and the input radiations, everything monitored. So all the weather conditions are monitored, output also monitored. So variation is there means, so we know this radiation, this time, the what is expected output, but it is low means what is the problem, like that we can monitor, so that the maintenance and effective utilization is possible. And somewhere direction change, axis rotation also through solar based monitoring or IoT based sensor based monitoring is there. Here a huge data, not solar means not like a kilowatt. Nowadays megawatt panels are there, so huge data is there. So data collection is nowadays very important. So now the technique is using cloud computing, big data analysis. We are using all the even solar, wind. Met mast means before installing a windmill, there is a unit called met mast. There whether all conditions are monitoring, like solar, everywhere we need a huge data. So nowadays cloud is possible, cloud data. So that is also connected, big data and cloud. So IoT and cloud computing together, it is possible in a all the interconnection of or interoperating of all solar, wind. So smart solar system means so the solar direction change based on the sunlight and the rotation. Like these are actually available things. This is a circuits for IoT based control, smart house. In there, this is a main chip, Raspberry, and relay and control for switches, all the things here we can see. Finally, nowadays it is called Internet of Energy, IOE. So Internet of Energy means IoT plus energy efficiency or energy application. So this IoT is used for energy applications means it is called IOE, Internet of Energy. So all the power generation is there, distribution, transmission, and all applications are there. Here one example, charging during off-peak load. So if off-peak load means there is no demand, users are taking less power. So excess power is used for charging, energy storage. How this is managed by means IoT based sensors calculate actual load available, actual power coming from the generating part, generating side. So this is easily immediately switch on the charging. Again, immediately load side is increasing, that is peak load. Loads are connecting fastly. Immediately this discharging is, charging stopped and discharging is happened. Like if needed, discharging. If not needed, only the power itself managed. Only the load, the generating power itself managed to connect the load. So energy internet in network, the all diagram, all the appliances, commercial or industrial or electric vehicle, everywhere connected through IoT. That is wireless sensor or wire with wire, whatever way it is connected. So that data is going to, there is a centralized or AI-based calculation also possible. So there it is not only connecting utilities, connecting the renewable energy source or fossil power plants, whatever available. So generating side, utilization side, both managed. That is energy internet network structure. That is a grid or central grid area. There they are managing like that only. So machine learning algorithm, a lot of things used for AI and IoT combined operation. A driverless car, like many applications already there, weather forecasting. These are some programs, machine learning programs. support vector, linear regression, lot of programs are there, K nearest neighbors. These are already in the research review. So machine learning algorithms used for AI and IoT together for many research, not only energy, other side also gear example. And the recent trend blockchain is coming for IoT, blockchain and IoT together for energy applications. So this is recent research area. I'm not going to explain. And another one is using the drone. Nowadays, the drone number is increasing hugely. So smart harvesting, everyone know the agriculture. So the drone identify the pet, all the problems in the soil or crops that can be used to take decision. Like smart energy harvesting, drones can be used for solar, wind, all the energy side monitoring and making decisions. So with that, I'm concluding. So energy optimization is a must one. Energy conservation. So take our energy in a better way using AI, IoT techniques or all the optimized way. We have to save our planet, save our earth. A lot of references there. I will take a few examples. So thank you so much for your patient listening. All the best. Now, any questions we can discuss.
I had just made a small question
Okay.
on the chat.
On
On the chat.
clearly.
I just wanted to know the difference between the different IoT layers and the networking layers when we make any program on the computer or IoT.
So actually, basically, 3-layer network must needed, but I have gone fastly. Lot of networking layers are there. Minimum application layer, network layer, perception layer. If lot of things means 5-layer means business layer also added. Service management. So better operation, better decisions.
Okay, this will be part of application layer in the networking layer, isn't it?
Yes,
Computer networks.
Yeah, this is the actual.
All these layers that you have introduced, new layers that you have introduced, business layer, and then service composition layer, service management layer. This will all be a part of
layer.
application layer.
Yes, sir.
Right? Yeah. Okay.
Yeah, but AI coming means this. For example, these blue colors are covered by AI. AI is used for or AI is applied to these layers.
Okay. Fine. I got it. Oh, thank you.
Thank you, sir.
So much, sir, for such a beautiful and lovely talk. We gained a lot of knowledge and enjoyed your presentation. I hope all the participants get benefited from this. Any more questions from the participants? You may please turn on your mics and ask your required questions. Okay. Take chances, make mistakes. That's how you grow. Pain nourishes your courage. You can have to fail in order to practice being brave. Now, I would like to invite Engineer Yuvraj Singh, Coordinating Committee Member, YCT, for the formal vote of thanks.
Thank you, ma'am. Am I audible, ma'am?
Yes, sir.
Good afternoon to everyone. I, Yuvraj Singh, Assistant Professor, Electrical Engineering Department, Yogananda College of Engineering and Technology. It is immense pleasure for me to propose a formal vote of thanks on the 4th day of FDP, Clean and Green Energy for Sustainable Development, organized by Department of Electrical Engineering. I express my gratitude for formal vote of thanks to the resource person of the day, Dr. M. MARSALINE, BENO, Vice Principal, St. Xavier's College of Engineering and Technology. Sir, I hope your talk will be very beneficial to the participants. We are extremely thankful for your precious time. In future also, we will need your cooperation for further such type of activities. Thank you so much, sir. I also propose formal vote of thanks to Engineer B.R. Burma, Chief Coordinator YCT, for sparing his precious time. I propose for vote of thanks to Engineer Dinesh Gupta, Dean Academics, YCT, who always encourage us to do such activities. I also propose a formal vote of thanks to Engineer W. Narwar, HOD Electrical Engineering Department, who always motivate us and work as team for such type of activities. I would also like to thank faculty of electrical engineering and faculty from other departments of YCT. I would also like to thank various participants who are attending this FTP. Last but not the least, I would like to thank our technical team. This is all from our side for today. Thank you. Have a nice day to all.
Thank you, Yuvraj sir. In the end, I will please, if all the participants, I request, please put your camera on for the group picture for the 4th day of FDP. And the feedback link will be shared in the chat box. Please fill it up. Thank you, everyone.
Yeah, Yasmin, ma'am, it's done.
Yes, sir.
Okay. So thank you once again, Beno sir. You spare your precious time and become the part of this FDP program. Thank you so much, sir. Thank you so much.
Thank you, sir. I too thank for the opportunity. Thank you all. Thank you.
Sir, I have a personal request to you. On tomorrow at 1 p.m. we have valedictory function. So I request you to please spare some time for half an hour for valedictory function. I request you to please join the valedictory function by tomorrow at 1 o'clock, because on tomorrow we have a session by Dr. Nazar Ali sir from 12 to 1 o'clock, and after that we have valedictory function. So I personally request you to please join the valedictory function, sir.
Sure, sir. Thank you for the invitation. I will join, sir. Thank you. Okay, sir.
Thank you so much. Thank you so much. No, once again, thank you, Beno sir. Thank you all the participants to become the part of this FDP program. Thank you so much.